Try again here. It's chapter 12, section 3. Regular pyramids have regular bases. You'll get the condensed version, the Cliff Notes version. Have regular bases, and they have one vertex, the point of that pyramid. Their height is the altitude that goes perpendicular to the base. And coming down that face, right in the middle, faces are always what shape again? Triangles. Coming right down the middle, perpendicular to the base, is going to be what's called the slant height of that pyramid. So we can have lateral edges where the two faces, sides meet, and we can have base edges where the base and the side meet, the lateral face meets. A right pyramid, which is all my wood examples down there, are going to be pyramids whose altitude hits the center of the base. We have they called this non-regular. It's also an oblique pyramid, where when I go the altitude, that perpendicular piece from the vertex does not hit the middle of the base. Our formulas that we start with are for regular pyramids. So there are examples, wood examples over there. We're going to develop the formula, see why the formula is what it is for the for the lateral surface area. So if I take this, what is that, 5-sided pentagonal pyramid right over there, and we open it up, cut it down those lateral edges so that we have a net. Remember, that's just all opened up. This one happens to be a star. Very good. It is. And I want to figure out the area of all these triangles out there. Well, we know how to find the area of a triangle. What's the formula for the area of a triangle? 1/2 base times height. And the height of this triangle is the slant height of that pyramid. So I have 5 of them, 1, 2, 3, 4, 5. So right over here, they have done 1/2. Now the base of that pyramid, they're calling S for the side of the base, that base edge. So it is the formula 1/2 base times height, but 1/2 side length times height of the pyramid, which is slant height. And we have 1, 2, 3, 4, 5 of them. Then they factored out 2 things, the 1/2 and the slant height from each of them. So 1/2 L got factored out, and we left all the S's there that we could add together. And if you add all these side base edges together, that's called the what? Perimeter. So there is our formula for lateral surface area of a pyramid. On the left-hand side of your formula sheet, that would be a good thing to write down. The title is Pyramids, and the lateral area is 1/2 perimeter times slant height. So you can say 1/2 PL, but that doesn't really tell us anything. 1/2 perimeter times slant height. So find the lateral area of this square pyramid. Lateral area, 1/2 the perimeter times slant height. So 1/2, what would be the perimeter of this one? 16. 4 inches, 4 of them going around, 16. What is the slant height? 6. I made it too easy. What's half of 16? 8. What's 8 times 6? 48 inches square. See, geometry is always just easy. Surface area. When we say surface area, we're talking about the total surface area. If we already have found the lateral area, what is the only thing missing for the total surface area? The base. How many bases do we have? 1 of them. So plus 1 base. So the next thing, total surface area, it's just the lateral area, which is 1/2 perimeter times slant height, plus area of the base. And again, that's why we use a capital letter B, because we're standing for the area of that base. So, pretty simple. Let's try it out down here. We want to find the surface area of these square pyramids. So they tell us we have square bases to them. So my surface area, 1/2 perimeter times slant height plus area of the base. So 1/2, do I know enough to do the perimeter? Not yet. So we're going to have to do some figuring out. Now look carefully in that pyramid. The 11 is pointing to the what? We have a name for it. Slant height. What is the 9 pointing to? The altitude or the height of that pyramid. But I can draw, and they have already done it, a little triangle coming across the base here that is inside that pyramid. And I can figure out how far it is from the middle of the base out to the edge over here by using what? Pythagorean Theorem. Is that one of our special triples or special triangles? No, it's not. So let's call that bottom piece x for a minute. 9 squared plus our x squared would equal 11 squared. So I'm going to subtract that 9 squares to move it over. Then you are going to take the square root of this and tell me what is that x distance. 6.3. 6.3 exactly? Let's go at least to 2 places. 6.32? My equal sign kind of ran together down there. We'll change it. 6.32. How can I use that distance, 6.32 now? Multiply it by 2, and I have my total distance across. So 12.64. So now let me start filling this in. If I want to find the perimeter, 12.64 times 4. So I'm going to call it 12.64 times 4. Now that's just my perimeter. Now I'll multiply it by my slant height, which is 11. Plus, how are we going to get the area of that base? 12.64 times 12.64 or 12.64 squared. Run that through a calculator. Let's see what you get. You need to bring one. 716 point, nearest 10th. 0.3? 716.3 or something different? If you have something different, go ahead and say. Maybe everybody else got something different. I don't know. So if you round to the nearest 10th, 437.9. Is it 8 or 9? Look at the whole thing. 9. Well, it depends on what the numbers were. Is it 8.4? Yeah. Then if it's 8.4, it's 8. Well, if you round it to 2, it's 8.5. But you can't round and then round again from the rounding. You can only round once. 400, how much? 400.8 inches square. And that's a good thing to remember when you are doing your work. Don't round twice. You can only round once. So if I work on this one, well, I know my surface area is 1/2 perimeter times slant height plus the area of the base. So 1/2 of, can I do perimeter on this one? Yeah, 40. I know 10 coming across. So 40. Do I know the slant height? 13. Hey, this is turning out to be easy. How about the area of the base? 100. 10 times 10, 100. So that gives you 360 meters squared. Not so bad. Let me show you how to draw these pyramids if you need to draw them. So I can get them even if, yes ma'am?
I need to turn in because someone
Locked you out of the computer, huh? Brittany is the only one. If you're going to draw a pyramid, first draw the base. So it looks like a parallelogram if we have a square base or a rectangular base. And then put a little dot right in the middle of that base, right there, and go up above that dot, and this dot is going to be the vertex of your pyramid. And then all you have to do, and I should have started with straight lines. Let me start with some straight lines. Is go from that vertex down to that corner, down to this corner, down to the corner in the front, and then make the ones that are really hidden dash lines. I shouldn't have used that for my dash line. Make the ones that are hidden a dashed line. And you can do that faster than I can, because see, I have to come over here and say a dashed line. Which one shall I use? That one. There you go. And you've got your pyramid. So it's not hard to do. Just draw that base and then use that dot. And some of you are artists, so you don't have to do this. But if you're not artists like me, That's how you can do it. You can get a nice pyramid. All right. Let's hopefully turn to the next page. There we go. Find the surface area of the regular pyramid, round to the nearest tenth. So we know the formula is 1/2, help me out. I want words instead of letters. Perimeter times slant height plus area of the base. Very good. So I can get the perimeter out of this one. That's easy enough. Tell me the perimeter of our, what is that, a hexagon? 30. So 5 times 6 would be 30. I know the slant height. What's my slant height? 8 plus, now I need to find the area of the base. What formula do we use for an area of a polygon like that hexagon there?
Oh, the bottom.
1/2 perimeter times apothem. You can switch the perimeter and apothems if you want. So when you find these, it is very often that you will need to draw the base so that you can figure out what is going to be the area of that base. Now, they were very nice and figured some things out. How did they figure out that this was a 30-degree angle right there? 360 divided by 6 would give us the whole triangle. Cut that 60, 360 divided by 6 is 60 1/2, and we have our 30. And we know the apothem goes from the center to the middle of the base edge, so if it was 5 across, it's 2.5 right there. So how am I going to get the apothem? We have a 30, 60, 90 triangle.
Times it by square root of 3.
Square root of 3. I've got a special triangle, so I don't need to use my trig ratios. I can just take the short leg, 2.5, times the square root of 3, and I have the apothem. So coming back up here, 1/2 times 30 times 8 plus 1/2 perimeter again, still 30, times apothem, 2.5 times the square root of 3, and since we are going to a decimal, your calculator. What do you get? See if you can make that work correctly. If you want to take those 1/2 of 30s, they're called 15s, and that'll save you a little time punching in numbers. $185.0?
Yeah.
If we round, just rounding once, 185.0, what will be centimeters? Square for that area. Okay? So again, the key is using this base formula and then figuring out the numbers that will fit into it. So let's try it down here. We know surface area is 1/2 perimeter times slant height plus the area of the base. Do I know the perimeter? I'm going to do this one a little different, list all our values. Yeah, we have, what is it, 1, 2, 3, 4, 5, it's a pentagon, so 4 times 5, 20. Slant height, do I know my slant height? No, so we're going to have to do a little work. They have told us the height or the altitude is 7, so if I want the slant height, I am going to draw a line to the middle of this base edge, and then coming right up the center of that is the slant height. That is a right triangle. Can you see that inside the pyramid? That's a right triangle because that altitude is a right angle to the base. And do I know, what do I know? I'm going to have to do something a little bit different. It's not, I do know a 2, but that 2 is right here. That 2 is not coming across the bottom. We're going to have to work with 2 triangles.
Oh no.
Are we going to have to work with 2 triangles? We are. I'm going to make another one. Oh, which one do I want to do?
The easier.
I'm going to work with, can I even do that one yet?
Could you do the line to the center of one of the sides? Could you do? So that if you just drew to one of the centers, to the side point.
Let's get a length of one of these pieces in our triangles. Here's the base. Right there is the center. I know 4 is right over here. So why don't we work with this triangle right here? We know 2 is this piece, right? And I can figure out what this angle is. How will I figure out that angle? 360. We'll divide it by 5, which gives us how much? And then what will I do with that 72? We'll divide it by 2, 36. We know that angle is 36 degrees. So it's not a special triangle. But I can use, which one shall we find? Let's find this apothem right there. That's going to be useful to me. I'm going to get rid of that blue line right over there. So if I want to find the apothem, if I said, since 2 is the opposite, and A happens to be adjacent, we'll use tangent. Tangent of 36 would be the opposite 2 over the adjacent A. So I can multiply by A to get rid of it there, then divide by tangent of 36. So what is 2 divided by the tangent of 36 degrees? And let's go to 2 decimal places. Anybody else? 2.75? 2.75. Now, if I take that 2.75, let's come back to our picture. That is the apothem, that green line right there. 2.75. And we can use the Pythagorean Theorem to help us get this slant height right there. That's what we were trying to go for. So we finally found 2 sides. So I can now say 7 squared plus our 2.75 squared must equal that slant height, L squared. So if I take the square root of it, I'll know what slant height is. Tell me the 2 decimal places. Anybody else? 7.52? 7.52. Slant height, 7.52. Now we have, hopefully, we are going to have enough. We can start filling in our formula. 1/2 perimeter, 20, times our slant height, 7.52. Now, how are we going to get the area of the base? Right down here, we have a base. 1/2 apothem times perimeter. 1/2, do we know the apothem? Yeah, we found it, 2.75. 2.75. And our perimeter is still 20. There you go. So run it through your calculator. So we had to draw that base and work with some triangles down there.
Yeah.
102.7? Got a couple people who think it's 102.7? Inches square. Draw the base. It's going to be a very common thing we're going to have to do to try to figure out measurements that we don't know. All right? Moving on. There we go. Moving on to cones. So on the right side of that sheet of paper where you have your formulas, we're going to have some matching formulas for cones. If the lateral area, the side surface area, if the lateral area was 1/2, what's the formula on the pyramid again? 1/2 perimeter times slant height. And perimeter is the distance around the base. Well, if I have a cone, the only difference is I have a circle on the bottom. Circumference is the distance around the base. So if I started to say, hey, I know the original lateral area for a pyramid. It's 1/2 perimeter times slant height. So let's do that with a cone. 1/2 circumference times slant height. What is the formula for circumference of a circle? Whoa, that's the area of a circle. 2 pi r. 2 pi r. What's 1/2 of 2? 1. There you go. We just figured out the formula for the lateral surface area of a cone. James?
I find the surface area of like, you know, like kind of like a cone, but like with a base as an oval.
Well, we don't have it in geometry. It can be done, but not with basic geometry, because it's a different shape. Right cones, we have right angles between the altitude and the base. Oblique cones, just like when we were talking about the pyramids. When I go from the vertex, I don't hit the center when I make a 90-degree altitude out of it. That line between the vertex and the center of the base, which is the center of the circle, what are they calling it? It's always called the axis. That axis may be the altitude if it's a right cone, or that axis may not be the altitude if it's an oblique cone. Other than that, we have the same terms. Vertex, we have slant height coming right up the side. So our total surface area formula, if you fill this in, we have our lateral area, pi RL, plus the area of the base, and since the base is a circle, it's pi r squared. So you have all those memorized. The conical slate roof at the right, so right over here, happens to have a height of 16 feet, a radius of 12 feet. Find the lateral area. Okay, lateral area for a cone. What's that formula? Pi r L. Pi times radius times slant height. So pi times, do we know the radius? 12. Do we know the slant height? We need to get it. Now, look at that right triangle. Is it a special triangle before we go running off the Pythagorean Theorem? That's a 3, 4, 5. 3 times 4 is 12. 4 times 4 is 16. So 5 times 4 is 20. That slant height must be 20. Easy. Nearest tenth. What do you get? Pi times 12 times 20.
240.
240? Nearest tenth? 753 point. Is it 754.0?
Yeah.
754.0. Don't forget to do the whole formula when you are doing these problems. I don't know. There we go. Find the surface area of this cone. It says it's at a diameter of 14.8, slant height of 15 centimeters. So I know the surface area for a cone. What's our formula?
IRL.
Pi RL plus pi r squared. So pi times, do I know the radius? 7.4. Do I know the slant height? 15. Too easy. Plus pi times 7.4 squared. Yeah, they didn't even make us figure out anything in this one. What do you got? 520.8?
Yeah.
520.8 centimeters squared. Now, they made this one, well, they made this one too easy. But it wouldn't be hard if you needed to. You could draw an altitude, and you get right triangles in those cones with the slant height right out here. So if I needed to find the altitude, I could easily find the altitude. Little review. These are the formulas in the form of a table. Well, in a minute, these are the formulas in the form of a table that you should know at this point. You need these memorized, and we're going to add a few more, but you can handle it. But you need these things memorized. Let's go to the book. Oh, terrible. We are on page 589.
You mean 859?
Maybe we're on 859. That would be a little more accurate. Number 2.
What happened to number 1? We did number 1.
We skipped it. Number 2. No.
It's too easy.
Number 2 says find the lateral area and surface area of each regular pyramid. Tell me the formula on pyramids for lateral area. 1/2 perimeter times slant height. So looking at this, do I know enough information or do I need to figure some stuff out?
No, you know it.
We've got all the given information that we need. So 1/2 perimeter, what would be the perimeter?
35.
7 times 5, 35. What's the slant height? 9?
Yes.
Okay, so we get a lateral surface area, lateral area of, to the nearest tenth if you need to, 157.5. What was our unit? Inches squared. So when they want the total surface area, what's the formula? 1/2 perimeter times slant height plus area of the base. Well, we already have our 157.5 plus what shape is the base? Aha. So what formula are we going to use on that pentagon? There you go. I'm going to call it 1/2 perimeter times apothem. You can do it either way. And then you're going to sketch a nice pentagon so that we can work on figuring out what is the area of this thing. How far is that one side of the triangle there? We know that's 3.5 because the whole base edge is 7. We're going to need to find out what sort of angle we have right there. So take 360 divided by 5, then cut it in half. We end up with 36 degrees. We did one a minute ago. We're trying to figure out what this apothem is. So what are we going to use? Going to use tangent again. We know the tangent of our angle, which is 36, equals the opposite, 3.5, over the adjacent, which is that apothem. So I can multiply by the apothem, get rid of that fraction, then divide by the tangent of 36, and to at least 2 decimal places. What do you get for an apothem length? 4.82?
Yeah.
4.82. So now that we know the apothem length, 157.5 plus 1/2 our perimeter is still 35, and our apothem was 4.82. And now to the nearest tenth, what do you get for a surface area of this thing? So to the nearest tenth, how much?
What is 241? 241. You used the wrong trigonometry. 241.85. So I got 0.8.
0.8 is what the book is telling me.
If you leave it in your calculator, around
Yeah, and that's the deal. Leave as much as you can in your calculator. Number 4. A conical tent is shown at the right. I know you're having a hard time that I'm skipping numbers, but number 4. Some of you are not having a hard time. Number 4. A conical tent is shown at the right. It says round answers to the nearest tenth. Find the lateral area of the tent and describe what that lateral area would represent. Okay? Well, we know our lateral area formula is, what's the shape? I almost did the wrong thing. Yeah, we've got a cone here. We have this conical tent, it says. So what's our lateral area formula? Pi RL. So pi times, do we know our radius?
6.5.
6.5. It would be half of that 13. Do we know our slant height?
No.
So we are going to have to figure out a slant height. So if we had a cone, and it's easy to draw a cone, we draw what looks like an oval. I'm going to put a dot in the middle. I'm going to go straight above the dot. And then I'm going to come down to the two edges. Well, almost hit the two edges. Because I need to work with some other things in order to get my slant height right over there. What's the side of that right triangle? 6.5. Same thing as our radius. Do we know the height? Is 8. So I can set up 6.5 squared plus 8 squared would equal the slant height squared. So if I take the square root of it, I will have the slant height instead of the slant height squared. And why don't you tell me the 3 decimal places? 308. So if that's the slant height, then I can come back and put in 10.308, or leave it all in your calculator is even better to do, and then run it through the rest of the formula, giving us a lateral area of what to the nearest tenth? 210.5. That should be what you're getting. 210.5 feet square. They said, what does this represent? It's I'm just going to call it the tent material. Notice this one does not have any base. You have to just sleep on the ground. Represents the tent material, or the tarp, or whatever you want to call it. That was part A. Part B. Find the surface area of the tent and describe what it would represent. When they say surface area, they want us to include what? The base. So we know surface area formula, and again, one of the reasons I have you write it down, not only so you know what formula to use, but you memorize it that way. Every time you write it down, you're running it through your mind. So surface area, pi RL plus pi r squared. And we already have our pi RL, 210.5, pi times 6.5 squared. $343.2 is the correct number. Feet square. So what does that represent? Yeah, it'd be the tent plus the floor. We'll call it the floor instead of the base. Now, I'm not sure why they want us to include the floor, since the one they showed us has grass growing on the floor, but anyway. Number 6. Lateral area and surface area. Okay, what shape do we have? Cone. So lateral area? Pi RL. So pi times, do we know the radius? 7.5. Do we know the slant height? Not yet. How are we going to get that slant height?
Triangle.
Triangle and the Pythagorean Theorem. They already have this nice right triangle with what is one side? 15 is one, and 7.5 is the other. 15, one leg squared, plus 7.5 squared, the other leg squared, will equal that slant height squared. So when I take the square root of that, 16.77? Just leave it in your calculator, run it through the formula, and what do you get to the nearest tenth for lateral area?
395.
So nearest tenth, 395.1. Book agrees. What was the unit? Centimeters squared. Again, if you leave enough decimal places, you should get exactly what the book is getting. They want the surface area. Well, we know it's pi RL, which we've already found, plus pi r squared. So we have our 395, and I'd leave that answer in the calculator. 0.1, or whatever it was, plus pi, and our radius is what? 7.5, which has to be squared. So as much as possible, as many decimal places, or leave answers in the calculator, run it through here. 571.9 is what the book thinks. Centimeters squared. Very good. Your assignment. Page, was it 859? 859, numbers 2 through 26, even. Hey, that's a good idea. No, we have it there. 2 through 26, even.